Module 3, Security. One of the first questions with circuits you'll receive will be around security and data privacy. Business owners, or in the larger companies, the IT organization, will try to challenge you with fears and anxieties about whether users can be susceptible to eavesdropping and whether their data is secure in the cloud. Circuit is a cloud service, but it's delivered with a focus on data protection and privacy. Circuit's service delivery model is structured around three data principles: encryption, data protection, and data center security. Here you'll see the various aspects of encryption. Encryption of the browser signaling through Transport Layer Security, or TLS. Secure WebSockets. Real-time traffic encryption through SRTP, Secure Real-Time Transfer Protocol. Session key protection. And strong authentication of browser sessions. When users upload files into Circuit, they're checked for viruses and malware before they're stored. Infected files will not be saved. In order to limit the effect on user experience, scanning is not repeated during downloads. This graphic shows the browser attributes of the secure connection established with the Circuit Cloud environment. It shows information about certificates and the way the connection is encrypted. When it comes to data privacy, separation is important. Each customer has administrative control over their Circuit domain and is able to see the data and the related activities of their Circuit users through the role of the Circuit Tenant Administrator. Personal data is being collected and handled within Circuit according to certain regulatory requirements, and is made sure that log and trace files do not contain any readable pieces of personal data. Any other confidential data will be deleted or clearly marked as that and hashed where needed. Establishing strong password policies is a clear requirement in an environment where data security has the highest priority. This slide describes the various aspects of our password policies. Here you can see information about how the data is being handled. When the tenant runs out of available storage, they can either reduce the amount of uploaded data or purchase more. We also accommodate requirements to allow access to data by law enforcement or where data is a public record. For the application architecture, this slide provides a lot of details. You may pause the screen at your leisure to read through these items. We've added a couple of architectural aspects to this chapter, although they're not directly related to data security. This one talks about the way the software as a service offering can scale in a cloud environment. We make sure that there's always enough resources available so Circuit can grow without concerns about reliability, resilience, or performance. In some of the previous slides, we explained to you how Circuit deals with data security. But data security really starts with the data center and access security. Here's a couple of aspects regarding our public cloud data centers and how we treat them as secure as a bank vault. Resiliency is important when it comes to an always-on cloud service. Here you can see what measures have been taken to guarantee this type of resiliency. It spans from power to networking to computer infrastructure and includes comprehensive monitoring. And here you'll find some operational aspects that make the Circuit Cloud a secure environment, not just a certain point in time, but also at any time in the future. You may pause the playback if you'd like to look at this information in more detail. Last but not least, here's some data points on how much traffic and data consumption is to be expected when you use Circuit. The network impact of Circuit is an important consideration for development. As a cloud-based collaboration solution, Circuit can generate traffic between users and the Circuit data center or between individual users in peer-to-peer sessions. Circuit uses WebRTC technology to connect users' voice, video, and data. All Circuit usage will result in a very small amount of overhead traffic between a user and the Circuit data center. Uploading and downloading files will result in bursts of traffic just like these actions do with any other application. Real-time sessions generate traffic that consumes bandwidth that varies with the call type as shown in this table. In any Circuit deployment, There will be a distribution of call types, and this chart also shows a general model for that distribution. Typically, users access Circuit over the internet, from the corporate network, or from a remote location. UniFi recommends that Circuit traffic from remote users not originate from VPN connections, but instead route directly from the internet. Keep in mind that real-time sessions between two users will generate peer-to-peer traffic between those clients, and not between the users in the Circuit data center. However, multi-party calls with 3 or more users will be anchored in the Circuit data center. This means that the traffic users generate will need to traverse your firewall and get to the internet, and that standard voice over IP practices will apply to achieve acceptable conversation quality. So in this chapter, you learned that security in the context of Circuit has many facets. We're taking care of the data security and privacy, but we also make sure that the data centers are built and run with the highest standards.